Alright, so someone wanted a video about how to set this guy up to null coax. This is a pardon the mess, because I've been pretty much working on that guy. So this is RG400 half wave. Same setup as I did before, just I'm using the 50 ohm stub end here. So let's go back here. And so this is on. This is center frequency is 27.025. Very important to have a smallest bandwidth possible. Mine's 2 megahertz, and you want 201 calibration points. The wider you go in this, like if I want to do 10 megahertz, well, the resolution you get in all of this is then pretty bad. Anyway, so to null coax, you want to ignore this. Like I have mine popped up to SWR immediately. Well, obviously that's not going to be right. But you'll notice here, these are really close to being straight on your Smith chart. Now, there's other videos to explain Smith charts. I'm not going to try that. That is a very complex and very deep subject. But for nulling, it's actually not that hard. So we're going to click screen, and I'm doing this through my screen here. So we want to go to display. We want to select trace. So, and these are color coded, trace 0. Go back. We want to go to format. Now format tells us what we're looking at. So we're going to get rid of the SWR. We want to go to phase. So your Smith chart is still displayed in the background. However, it changed this to your phase angle. So nulling coax, especially in half wave, is when your phase shift happens. So this is dead in the middle of this band. There's your phase shift. That is nulled. Now it's kind of weird and counterintuitive, but if you go to your Q factor, which is on the next page, more Q factor, you'll notice right here we have a null. And let's get my marker over here. Right there. So that your Q factor means it's a resident at that frequency. That's the resident point on that frequency right there. So that is the absolute simplest way to tune coax. You cut it long, and if you go back here and to do phase, you'll start, as you keep going, this phase angle will continue to move down every time you trim it. Now, the one thing really important for someone who's just starting out, this is your calibration point. Now, obviously, I can't calibrate it with this T, but these measurements are taken at the end of this SMA cable, which is connected all the way over here. So I calibrate it basically right there. So this is actually part of this display, which this little bit isn't going to matter at all into this. What I'm looking for is this null right there. So this is your phase angle. That is the absolute easiest way to null a coax, and it works for any length. Now, rules of thumb. What I'm doing here now, beyond my knowledge set, this works for half wave only. But here's the real catch. It can be any length half wave. So if it's 4 wavelengths, add a half. So it's 4.5 wavelengths, this works. Okay? Anything below a half wave, which you can go quarter, which is, we're not even going to go there, you don't need to do this. You can just plug it in here, make sure you're nulled at wherever you make sure this is calibrated here. You don't need to do this then. It works for half waves and over. I don't know why this is needed. I'm assuming that the 50 ohm resistor gives a counterbalance, and then you're measuring this. Now, return loss, this is not a this isn't an MFJ where you can measure return loss. Okay, so return loss is your Q factor, the least amount of reflected power. That means this cable, everything here is resident. The more returned power, your Q factor goes up, if that makes sense. And I could be completely wrong, but this is the way it was explained to me. So, in short, all you need to do is set this up here. Now, you need these guys, but phase angle, that's all you need to tune a coax. There's nothing special about it. And hold on, I will pause the video. Okay, so here I connected all the way. So we're going out, going through coax, and back in. Things are going to look different here because you're cutting out this. Now, this is phase angle again. Now, you can also see we've changed a little bit. We're no longer showing a phase angle here. We're at 160 degree phase angle. Why? Because our little bit over there added some. Now, I'm not worried about that. I've actually had more trouble landing dead on a phase angle shift, and certain things, I'm not talking what, misbehave themselves. So this tuned right here is perfect. So if you want to double check it, you come over here, hit SWR, is 1.049. Okay, so I'm trying to get this to focus here. Oh, there we go. So right here, this is measuring your loss, 0.16 dB. Now, RG400 is remarkably lossy already, so that's to be expected. But this is the loss going through this entire loop. And you can also see it on our Smith chart, or nothing. So you can come over here, Q factor, it's basically non-existent. This entire system here is completely resident at this frequency. I know it seems really confusing, but this is way I have nulled all of my coaxes, and it works. It just 100%, there's nothing to be wrong with it. Now let me show you one other thing. Okay, so the next thing I changed was I've now disconnected and just put, you know, this was already assembled, a 50 ohm load. To double check it, I'm come on, focus, there, 1.07 SWR on that loop. Perfect. Come in here, more Q factor. Perfect. Now, at this point, you're going to say, well, what about the phase? Well, phase doesn't really matter here. Again, like I said, because you no longer have this, your phase isn't going to be perfect. See, we're negative 148 degrees. We're not really worried about that at this point. What you're now worried about is what your SWRs are through there. And honestly, I have made so many of these cables exactly like this. I have not had one fail. I've did a 300-foot coax run doing exactly this. Everything worked perfect. I hope this answers some questions. It's not hard. You just need to follow this, put the 50 ohm dummy load on this side, and cut your coax long, and just watch your phase angle. As soon as it keeps, you know, if you're long, it's going to be either side. Generally, if it's going to be long, it'll be coming lower frequency, higher, and crossing your screen. If you get it perfectly center, by the time you get all this, you know, 180 degrees is complete phase shift. We're 40 degrees out, but this doesn't matter. You've still nulled this coax. It is a perfect SWR match. It's perfectly fine. Now, there's also things to realize that you need to cut it for velocity factor and all that good stuff. But, and RG400 is a pickle anyway, but I hope this answers some of the questions that you have